Thanks everyone for coming down this morning, or this afternoon now, to hear about AI Cirus. So AI Cirus is an acronym for Artificial Intelligence Spectral Infrared Interpretation System. It's a cloud-based service to automate the processing and interpretation of infrared data collected from portable infrared spectrometers. We focus on that part of the market because we find that that's where the majority of the instruments are. The big core scanning systems are fantastic, but people need that cheaper entry point and be able to deploy the systems to site quicker and easier. So the handheld spectrometers is what we focus on. And AI Cirus is a service that's been in index for a couple of years now, and it's continuously being developed and progressing with new minerals being added and new functionality. So I'm going to run you through a quick demo of what's involved. So the interface is very simple, intuitive, user-friendly. There's a main menu on the left-hand side. See if the mouse pointer's working there. We start off with this sync button. So we do this bi-directional flow of data where customers would upload spectra to the cloud. It goes through the processing interpretation engine, and then they synchronize again to download the mineral results. So I've got 3 projects listed here, and the projects are defined by 4 components: by the company name, the country of origin of the samples, the region, and the project name. So when they upload their spectra, they upload it to a project path, and we use that to sort of store and manage the data in a secure cloud-based system. So we start off by importing the spectra, navigating to the directory where your spectra is stored, telling the software, the app, which project path the data are going into, and then we step through a series of metadata imports as well, where you can bring in your downhole depths, your drill hole IDs, so that we can use that information to plot the mineral results downhole as strip logs. So once we've imported the data, we come to the QA/QC step, and this is to ensure that we're receiving good quality data so that we can deliver good quality results as well. On the left-hand side is the list of the spectra that have been brought in, and on the right-hand side up the top is a plot of the spectrum. So both the import spectrum is shown in blue, and then a background hull removed version of the same spectrum, which allows us to see the absorption features more clearly. So the absorption features in the spectra are manifested by different processes going on in different parts of the electromagnetic region. We focus on the visible near infrared to the shortwave infrared, which is from 450 nanometers to 2500 nanometers. And in the visible part, it focuses on electronic transitions within the minerals, and the shortwave focuses on molecular vibrations within the mineral lattice. So those processes manifest these absorption features that are diagnostic of the minerals. So we're able to tell things like the composition and the crystallinity of the minerals based on those features. Down on the bottom, on the right-hand side, is where we have the metadata stored. So you can see the drill hole ID, the from-to depths, the different details in terms of the spectrometer type that was used and the integration time, etc. And the very bottom here is our color-coded QA/QC checkbox. So when you see all the boxes colored green, that means it's good, everything's fine. If they're yellow or red, it's bringing to your attention potential problems with the spectra. Those things could be things like dampness. We need the samples to be dry and free of any grease or plant matter to get good quality mineral spectra. And if there's anything like problems with the spectrometer itself, if there's noise in the data, we pick that up and we flag that for the user. So they have the option of rejecting the spectra before it's uploaded to the cloud. So once you're happy with the spectra that you're ready to upload, you click on the sync button. It's a little icon down here with the arrow pointing to the cloud, nice and simple, very straightforward. It gets sent up to the cloud to the AI Cirus processing engine, where the mineral results are generated, and then you synchronize again to download the results. So once your results are received, you can come to the view screen, tell it the project path that your data is stored in. We have a series of different plotting templates, and for this particular demonstration, it's for a porphyry epithermal system. So we've got a series of plots already set up with different analytics that we calculate automatically from the data, and we pre-populate these graphs, scatter plots and histograms with your information. So I'll show you an example of what that looks like. In the top left, we've got the drill hole collar location plan. And if you hover your mouse over it, you can see the drill hole ID for each hole. In the top right, we can load up multiple drill holes side by side. Now these are just strip logs. It doesn't have the survey information here. It's a bit squishy, so if we open it up in a new window, you can see the depths down hole on the left-hand side. The color coding is reflected in the legend on the right-hand side here. And the squiggly line down each side is a measure of the depth of the main feature in the spectra. And this is giving us an indication of the alteration intensity downhole. So each of these can be saved as image files and put into reports. This particular function in the lower left, I'll open that in a new screen. Again, we have the downhole depths on the left-hand side. And the first series of columns under minerals is each mineral that has been detected in the data set, plotted up by its spectral contribution. And the spectral contribution is a relative abundance term, so that we can say the relative proportion of certain minerals found within the spectrum. Only the minerals that are infrared active, so we're not picking up things like anhydrous silicates or sulfides. On the right-hand side is a series of all the different parameters that we automatically calculate and export for you. You'll find that some are really key and powerful for your particular project, and other ones may be less so. So each data set and each project is going to be different, but we give you the results in a standardized template reporting. On the right-hand side, using this scroll bar, you can see that there's a series of scatter plots and histograms as we go down. Again, this is pre-populated with the customer's data for each project. And we have a results information sheet that we can distribute that explains what all the different metrics are. For this top left one, for example, we have the wavelengths of the white micas on the x-axis and the white mica crystallinity on the y-axis. So these are two very powerful parameters when you're working in an epithermal environment. The white mica chemistry is often indicative of the pH of the environment, so the shorter wavelengths are associated with a lower pH, more acidic formation environment conditions. And on the y-axis, the white mica crystallinity is telling us about the thermal conditions of the environment. So it could be telling you about proximity to a hydrothermal upwelling or hydrothermal conduit. That is very important information to have from an exploration perspective. So that's the plotting perspectives, and we also have a further plotting tool called the dynamic log, which was added just recently or within the last year. And this allows us to look at all the different parameters on a per hole basis. So I can expand or collapse them all on a needs basis. I'll expand them out and just quickly go through them. So the first one is the combination strip log, and I'm doing it on a per hole basis. So this is for drill hole 352. I can right click and bring up the legend. If I want to look at the spectra of each sample, I'm able to do that as well. And this plot window can be updated on the fly. So as you click down, you can start seeing what the spectral characteristics of the mineralogy is. And you can start getting your eye in with different alteration facies. So you're seeing where the advanced argillic alteration is as opposed to the argillic alteration, and pulling out other alterations, facies in different systems as well. If I scroll across to the right, you can see that we've got a per mineral plot for each of the minerals that have been detected in your project. We can turn these on and off. So if you've got no gypsum or jarosite or only one or two of those, you can remove those and have it condensed to just the most important prevalent minerals in your system. Moving across further, we break it down for mineral classes into mineral species. So if you've got white micas, chlorides and alunites in your data set, we can refine it further by pulling out the compositional gradients within those mineral classes. The alunites, for example, we're able to distinguish the potassic from the sodic, and this is important again for prospectivity indicators where there's a thermal definition or thermal gradient between the potassium and sodium substitution. Scrolling across further, we have a series of the QA/QC metrics that are automatically calculated for you. And then finally, the parameters, all the analytics that are calculated for your project and automatically delivered. So it's one thing to see them as strip logs in the desktop app. We also give the option of exporting the results to a CSV file to take straight into other 3D mine planning visualization packages like Leapfrog or Micromine. And we can also save it as a gas file to take it straight into IOGAS and integrate it further with your geochemistry. So IOGAS being another one of IMDEX's software products. So the main things are the app is free for all users. AI Cirus is a cloud-based system, so we provide the app, the user uploads the spectra themselves, they download the results themselves, and they receive their billing once a month if they're using AI Bureau, or they can purchase a bulk lot of spectra up front using the AI Swift option as well. And I can go into detail with the two offerings for those that are interested as well. Okay, so that's a wrap for the demonstration of AI Cirus today. If anyone's got any questions, I'm happy to answer them.